this is an iHeart podcast. Guaranteed human.
Hey folks, owning a home means one thing. Something's gonna break. AC, plumbing, fridge, and it's never convenient or cheap. That's where American Home Shield comes in. An AHS Home warranty can help protect your wallet from pricey breakdowns on even your oldest appliances and systems. And if they can't repair the covered item, they'll replace it. So check out American Home Shield and get 20% off any plan at ahs.com/SYSK and see promo details. See ahs.com/contracts for coverage details, including service fees, limitations, and exclusions. American Home Shield. Don't worry, be warranty.
Work can be a little weird. Cringy training seminars, coworkers who won't stop talking about their plant, forgetting the mute button at an inopportune moment. We have to deal with a lot on any given workday. Sometimes it can feel hard to thrive and move forward in your career. Well, that's where LinkedIn comes in. LinkedIn helps you get ideas and insights from experts in your field, connect with people professionally, grow your network, and access tools designed to help you find the right fit for your next role. Whether you're just getting started, figuring out your next move, or looking to accelerate your career, LinkedIn is built to support you at every stage because LinkedIn is the network that works for you. Visit linkedin.com/knowstuff to learn more.
Welcome to Stuff You Should Know from HowStuffWorks.com.
Hey, and welcome to the podcast. I'm Josh Clark with Charles W. Chuck Bryant, with Jerry Rowland, with me, Josh Clark. And this is Stuff You Should Know featuring Josh Clark.
About to say, you never introduced yourself, and then you did it twice.
Three times.
Oh yeah, you always introduce yourself. Yeah. But you never say your last name. I think that's what struck me.
Josh? No, I say I'm Josh Clark.
Do you?
Yeah, every time.
I should listen to these sometime.
Yeah. That explains the glazed over look in your eyes whenever we start.
Mm-hmm.
Bridges. Yeah.
Is that your intro?
Yep. I like them.
Maybe we can add like a scat drummer on top of that.
We have that kind of when we're doing listener mail. There's a little bit of D.
Oh, yeah. Well, that's not scat drumming. I would say that's more of a shuffle.
Scat's like...
Yeah.
Like that?
Yeah, you should get Hodgman to scat for you sometime. He's good.
Oh, I'll bet he's good at it. Scatting, yeah.
A lot of boop-boop-ba-doos going on when he's scatting.
Any jazz hands?
No. It's not exactly Manhattan Transfer level.
Oh, he's intermediate?
Yeah.
Yeah, so again, bridges. Ta-da.
Yeah, I bet we're going to hear from some folks because there are bridge enthusiasts.
Yeah.
Which I think is kind of neat.
Yeah, well, I mean, they're like modern marvels of engineering. And actually, there's some ancient marvels of engineering, too, as far as bridges go.
Just about to say that, dude.
They are, you basically, I was talking to our pal, Adam, the architect.
Oh, the bridge builder?
No.
Yeah.
He's a building builder. Or a building designer.
Yeah.
I don't know if he actually knows how to build the buildings. He just knows how to tell other people how to build them.
I bet Adam can't swing a hammer.
So he was saying that basically the structural engineers who design bridges are just straight up geniuses.
Oh, I'm sure.
Like it requires basically a genius to factor in all of this stuff.
Yeah, anyone can design a building. There's just 4 walls and a bunch of floors.
Right.
Put a roof on it.
Bridge, though, is different.
That's right.
There aren't walls, really.
There can be. Bridges of Madison County, they had walls.
Oh, yeah, they have walls.
Uh-huh.
I was going to mention the bridges of Madison County.
Yeah, I love those. That'd be a beam bridge, I guess.
Yeah.
With a truss.
Right.
A top truss. What's the top truss called?
A through truss?
Yeah, through truss.
And then below that, if it were below, it'd be a deck truss. But I don't know if that counts as a truss. It's more just like a house on top of the bridge.
I bet there's structural support there.
I guess.
Maybe.
I thought it was mainly just to keep the rain off of you when you cross the bridge, like just an extra little thank you for crossing the bridge.
I thought it was just to draw in lackey tourists who wanted to have their picture made.
Another famous bridge, the one that the Headless Horseman couldn't cross in the Legend of Sleepy Hollow.
Oh, yeah?
Wasn't that a bridge?
Sure.
Trolls live under bridges.
Bats.
Drawbridges are pretty cool. Have you ever seen Maximum Overdrive, the beginning of that movie?
It's been many, many years. I saw it again in the 80s.
I saw it again very recently, like this year, and it is
really.
It's maybe better than it was before.
It holds up as a crappy movie still?
Yes. Yeah. The whole soundtrack is AC/DC, by the way, which you should love. Whole soundtrack.
I do love that, and I do remember that. And didn't Stephen King direct that?
Yep.
Which he doesn't do much, right?
No. That may be his only one. It was definitely his first.
Interesting.
But there's a great drawbridge scene in there.
Did someone jump the span as it raised?
No, I think their car fell in or their truck fell in.
Oh, okay. Because usually the drawbridge scene is like, I can make it.
No, this one was you're all doomed.
Yeah. You're
kind
not
of
making
drawbridge scene.
Gotcha.
And let me also recommend Budapest for bridges. You mean I went to Budapest a couple New Year's ago?
Yeah, I went there like 20 years ago.
Okay, so the bridges are amazing. There's, I think, like 5.
Yeah, because they connect the two sides.
Buda and Pest, right? And each one is totally different. Like, it's just a completely different design.
Yeah.
And they're just all gorgeous.
Yeah, let's just start with a bunch of bridge recommendations. I'm going to recommend the city of Pittsburgh.
Oh, yeah.
I went to a baseball game there, and it's just gorgeous. Those beautiful bridges that you can see from the baseball stadium and the river.
That was when we were shooting
Lovely.
a Toyota commercial thing, right? Mm-hmm. Yeah. I stayed in the hotel and just ate chicken sog.
Right.
Just like a quart of it.
But you could see the baseball stadium out your hotel window.
Yeah, and I saw some bridges, too.
Yeah, you walk across the bridge to get there.
Right.
Or at least we did.
What else? Any other bridges?
Nah. Oh, well, Brooklyn Bridge.
Sure. Golden Gate Bridge.
Yeah.
Those are like the famous ones. They're barely even worth mentioning.
Yeah, but the Brooklyn Bridge is, for your money, it's which is free. It's a pretty great thing to do, to walk across it. It's just beautiful.
I have never done that.
Yeah, you should do it.
Even the Geico Lizard did it, and I haven't. That guy's like Australian or something.
Well, maybe we should just animate you and have you walk across it.
One more thing. If you want to know more about the Brooklyn Bridge, I don't remember which one we talked about it in, but there is a really cool documentary about the Brooklyn Bridge and its building by Ken Burns.
Oh, wow.
I believe it's on Netflix.
I'll have to check that out then.
Yep.
Because I like Ken Burns and Brooklyn Bridges.
Yep.
All right. You ready?
Yeah, man. So bridges have been around for a very long time. This article is by Robert Lamb and another dude named Michael Morrissey together.
Yeah.
I believe they were locked away in a closet for like a couple of months while they worked this out together.
Well, one of the first ones talking about ancient bridges that they mention in here, the Arkadiko Bridge in ancient Greece. Mm-hmm. Did you see that thing?
No.
It's really neat. I mean, it still stands. It's a 3,000-year-old bridge, and it's just kind of cool to think about, ancient civilizations and ancient times. People said, well, I want to get over there.
Right.
And I'm here.
Yeah.
And so let's build something to do that.
I need something to walk on.
Yeah.
Or drive my cart over.
It's that simple.
I saw the world's oldest bridge that's still in use is in Turkey over the Milas River, I believe.
Yeah.
From 850 BCE.
Do you know what that one's how it's constructed?
It is a single stone slab arch, I believe.
Okay.
No, it is a stone slab single arch.
Yeah, that makes sense.
Yeah.
Very basic.
Yeah, but the arch, it's super old, but it's still in use today.
Oh, yeah.
Because whoever figured it out came upon this very elegant solution to a lot of problems that a bridge poses. Because, as you were saying, when you come upon like a river or a creek or something, you say, I'm on this side and I need to be on the other side, so I need something to walk across. Mm-hmm. Yeah, okay, that's a basic solution, but the further and further you get, the more and more problems. Like as bridge builders say, mo span, mo problems.
Yeah, I guess what we should have said is, I want to walk across and live. I want to walk all the way across.
Right, I don't want to fall down.
No, I don't want to get halfway across and have it snap.
Right, so over the years, as people have come upon problems where you are going to build a bridge that will snap and kill you, they've come up with solutions to prevent that from happening. That's pretty much the pursuit of bridge building.
Yeah.
Is coming up with ways to prevent a bridge from collapsing.
Yeah, and a lot of trial and error over the years.
Yeah.
You know?
And a lot of real significant disasters. In fact, there's a Time magazine slideshow called Worst Bridge Collapses in Past 100 Years. And it's got all these photos of collapsed bridges and little descriptions and the number of fatalities and everything. But it's really interesting. All these different bridges have collapsed and failed for all these different reasons.
Well, and after each one, it's very sad, of course, but after each one, someone goes, oh, well, we should do this for the next one.
Right. We should not forget that bolt next time.
Well, that could be human error, true.
That's happened.
Yeah, I'm sure. All right. So should we start off with the BATS?
Yeah.
BATS. Beams, arches, trusses, and suspensions are the main components, the structural components of a bridge. It's very simple.
Boom. That's it. That's all you need to do to construct your own bridge.
And with these 4 things, you can make almost any kind of bridge. We're going to cover mainly beam bridges, arch bridges, truss bridges, suspension bridges, and then the super cool looking cable-stayed bridge.
It is super cool looking. Probably my favorite looking bridge in the world that I came across in researching this is a cable-stayed bridge, the one that's in the article.
Oh yeah, they look like sails.
It's gorgeous.
The big triangles rising up. It's lovely.
Yep.
But they look a little more modern to me. They don't have that classic architecture like the Brooklyn Bridge does, or like the Tower Bridge in London.
Yeah, I think that's why I like it.
Yeah, you like the modern look.
Yeah.
Yeah, you're a modern guy.
I'm super mod.
All right. They point out in the article, which is very key, what you talked about, the span of the bridge. Is the distance between the supports, and that's where it all goes down, basically.
Yes, that's
got to be strong there.
Those are something that every single bridge has: is a span and at least one support. Most likely 2.
Yeah,
you know. And there's different. The reason that there are different types of bridges is because different bridge designs, the BATS designs. What is it? Beams, arches, trusses, and suspension, they provide stability for varying span lengths.
Yeah.
So like a beam, if you have like a 50-foot span, just put a very long log over the span, and there you go. There's your bridge.
Yeah.
But as you get further and further along, you have more and more problems supporting that span, so you need different types of solutions, and the different length of the span calls usually for a specific type of bridge design.
Yeah, and generally there's a lot of overlap, of course, but beam bridges tend to be the shortest, followed by arch bridges and then suspension bridges.
Right.
And I think those the cable-stayed bridge is kind of a suspension bridge, so that counts.
Yeah,
right?
It's like a kind of a variation.
Yeah, but they can be very long as well.
Yeah.
Yeah.
Not quite as long as suspension bridges, though. From what I understand in this, the suspension bridge affords the longest span.
Okay.
So you got a big long span, it's suspension time.
Yeah, and they're also super expensive.
Yes.
Suspension bridges.
Because all the bridge builders know that you got a long span that you're trying to cross, you probably got some deep pockets, and they're going to milk you for it.
Oh, yeah.
Every penny.
Yeah.
Yeah.
Like, you need a suspension bridge? I'm your guy.
Yep.
All right, so let's talk about, there are a lot of different forces that can act on a bridge to make it not as stable. We'll cover a few of the other ones later, but the main 2 here early on are tension and compression.
Yeah.
And the very easy way to think about these 2 things is tension is like if you and I are pulling a rope, like you're on one end and I'm on the other, we're going to pull that sucker tight, and I'm going to fall over due to your massive strength.
I'm pretty huge.
But there will be some tension in that rope.
Yeah, tension
and maybe between us.
Is after you fall down?
Yeah.
And I'd start laughing?
Yeah.
There would be tension.
Sure.
But tension is the lengthening of something.
Yes.
Compression is the shortening of something.
Yeah, like a spring collapsing.
Right. So it's easy to visualize when you're talking like springs and ropes and that kind of thing. But if you're talking about just a single deck of a bridge, which you think of as one piece, it's tough it starts to get tough to visualize it until you realize that you have to look at like a bridge deck, like the roadway on the bridge, as really having a top and a bottom.
Yes, and forces, the compression acts in the downward motion.
On the top.
And the tension acts from the underneath coming up.
On the bottom, right? So the bottom of the bridge, underneath it, of the deck is going to be spread out under the force of tension, where on top, where it's being pushed down, compressed, that's compression.
Yeah, and they kind of in a weird way work together, even though they're sort of opposite things.
They're definitely related.
Yeah.
Right.
And what'll happen is if these, if you aren't a very good bridge builder, buckling will occur when it's compressed, on the top.
Yeah.
And snapping can occur on the bottom, when tension is at work.
That's right.
It all sounds very confusing, but if you just, all you gotta do is put your hand out and look at it.
Right.
You know?
And so, or if you take
and push down on your hand or up on your hand.
Right.
You know what I'm saying?
Sure.
Like that.
Yeah, like that. The whole thing becomes very, very evident when you look at a beam bridge, right?
Yeah.
The most basic form of a bridge.
Like if you dropped a log over a river.
Right. And this thing, this article uses the example of taking a pair of milk crates and putting a 2x4 across them, right?
Sure. Let's do that.
If you put a bowling ball on a bowling ball stand so it doesn't roll around.
Yeah, that'd be awkward.
On top of the, or right in the middle of your 2x4, which makes up your beam bridge deck, right? Mm-hmm. You're going to see that it bows, and what you're seeing is that on the top it's being compressed, on the bottom it's being tensed, right?
Yeah.
And what you've just done is add a load to that bridge, and there's two kinds of loads to start out with. There's a dead load, which is the weight of the bridge and all of its materials combined.
Yeah.
And then there's a live load, which is, say, the cars and the people and the trains and everything that add the extra weight while they're moving across it and everything. Yeah. And as you add this extra load, first of all, the bridge is already dealing with its dead load.
Yeah.
It's got to hold that up. That's job number one for a bridge.
Yeah, like if you had a 300-foot 2x4 and two milk crates, it's going to sag in the middle just naturally.
Right. And it might even break. And there have been bridges that have been built where the guy forgot to carry the one or whatever.
Yeah.
And they couldn't stand up under their own weight. And they collapsed from their own weight. They collapsed from the dead load. So job number one of a bridge is to support its own weight. Job number 1.1 is to support all of the live load, the traffic that goes across it as well.
That's right. And the two ways that you're going to do this to counteract tension and compression are dissipation and transference force.
Yeah.
Or transferring the force. So with dissipation, you spread out that force equally. You spread out over a wide area. And with transferring, you move the area of weakness to an area of strength.
Right. Which
pretty simple.
Yeah. They're kind of tough to distinguish sometimes.
Yeah.
You know what I mean? But for example, the best example of dissipation is the arch, which we'll talk about how that works in a second.
Yeah.
But suspension bridges are best at transferring the tension and compression forces.
That's right. So if you're talking about a beam bridge, that most basic kind, the other thing they're going to do to make it stronger, of course, is back in the old days, they used wood, then later iron, and then steel, maybe some concrete mixed in.
Yep.
But the size of the beam is going to be really important. Like the height of the beam is important because the top is going to experience stress, the bottom is going to experience stress, and the middle, not as much. So a good I-beam, a good tall I-beam is what you want.
Yeah, and I didn't realize that's why I-beams are made like I-beams.
I didn't really either.
Now. It's
Makes
because
perfect sense.
The center of the deck or the beam or whatever, any kind of beam, is going to experience the least amount of compression or tension. It's really the top or the bottom.
Yeah.
So you don't have to put quite as much material into the center of the beam as you do the top and the bottom to prevent buckling and snapping.
That's right. So with the beam bridge, you're going to add what's called a truss to make it stronger. This we'll talk about trusses more, but it's basically a triangulated strength. And you'll see a truss if you've ever seen a train bridge, like you see a truss on top.
Or in areas where they get a lot of snow, roof supports will frequently be trusses.
Yeah, and that's a through truss on top, we already said, and if it's underneath, then it is the deck truss.
Right.
And you can have both, but usually with the railroads, you'll see that top truss Not the same as a trestle. That's different.
Right.
That's like a roller coaster, you know?
Right.
So after this break, why don't we talk more about truss bridges?
Nice.
Stuff you should know.
We've all had the experience of calling a business and just wanting to talk to a real person. Not an automated voice pretending to be human, an actual person who can listen and understand and offer help.
That's exactly what you can do with Ruby. Ruby is the virtual receptionist company that takes care of your callers when you're unavailable in the middle of something or simply don't want to pick up.
That's right. They can answer, screen, transfer calls. They can take messages, collect payments, book appointments, and more, all while making the people you serve feel special.
And best of all, it can help you be more productive. For example, 9 out of 10 lawyers who use Ruby log more billable hours per day than the national average.
And other professionals like plumbers and technicians win more customers while being able to stay focused on the job. But whatever kind of small business you run, Ruby is built to save you time, earn you more customers or clients, and make meaningful connections with the people you serve.
It's available 24/7, 365 days a year, and 100% based in the U.S. See why more than 15,000 small businesses use Ruby. Visit ruby.com, or better yet, call them at 844-900-RUBY. Work can be a little weird. One minute you're in a meeting that could have been an email. The next you're trying to decode corporate jargon that somehow means nothing. And don't even get us started on the quick sync that turns into a 45-minute deep dive.
Yeah, well, the truth is figuring out your career isn't always straightforward. Whether you're trying to grow, pivot, or just stay relevant, it can feel like you're navigating it all on your own. Well, that's where LinkedIn comes in.
That's right. LinkedIn can help you grow your career, helping you confidently navigate your path with insights, ideas, and inspiration from your professional community. You can stay up to date with the latest trends in your field, connect with people who get it, and discover opportunities tailored to your goals, your experience, and what actually matters to you.
Whether you're looking for something new or just trying to grow where you are, LinkedIn gives you the tools and connections to move forward with confidence. Because LinkedIn is the network that works for you. Visit linkedin.com/knowstuff to learn more.
So, Chuck, no joke, trusses are one of my favorite things now.
It's pretty neat.
After doing some research into them, I'm like, I love trusses.
You're a truss guy.
Yeah, and it's because they're so elegant and simple. Mm-hmm. They're elegantly simple, basically.
Yeah.
So I saw this really great explanation where it was on Make Magazine, and I think it was called like Ask Make, How Do Trusses Work? Pretty straightforward. And it basically had like a great graphic of using popsicle sticks, right?
Okay.
Let's say you make a square out of popsicle sticks and you join the popsicle sticks together at the corners where the ends all meet.
Yeah, a little Elmer's paste, maybe.
Makes sense.
Uh-huh.
Seems pretty supportive, right?
Yeah.
But when you press down on any one of those joints, which is where the load's going to be centered or distributed most.
Yeah.
Remember the ends? The square shifts to the side, and all of a sudden you have a rhombus. Well, a rhombus is inherently less structurally sound than a square, which is why you very rarely see rhombuses in architecture.
Right.
Right? With a triangle, when you press down at any one of the joints, it distributes that compression or tension directly through the center of the beam.
Yeah.
So the triangle stays totally rigid. And when you add the more triangles you add, the more support you have. So they're like, basically like, as far as a shape goes, the superconductor of transferring or distributing compression or tension.
Yeah. That's a good way to put it. And that's why when you see that train trestle and that has that truss on top, it's got all those beautiful diagonal pieces of metal.
Right.
And it's not just for looks, even though it is cool looking.
No, one of the other great things about a truss is that they're, it's like just 3 steel beams or 3 aluminum beams. They're just 3 pieces of metal, usually, fixed together. And that's the other key that I left out. They have to be connected at the ends.
Yeah.
Equally distributed from each end, right? So let's say you drill a hole to rivet one side of the truss to another, or one end of the truss to another end. The other end has to be equally far away.
Right.
Do you see what I'm saying?
Yeah, yeah.
Okay.
They wouldn't just be like, oh, just drill that other one wherever.
So anyway, you have to, the place where the truss sides join together has to be on the ends.
Yeah.
And then, but one of the things that it allows for is for wind to blow through it easily.
Oh, sure.
That's a huge point about trusses.
Yeah.
They're not solid in that they don't put up a lot of resistance to when they allow it to flow through, which is really kind of what you want. We'll see when you're building bridges.
Yeah, I think even the covered bridges have, it's more of a lattice type thing on the sides, right?
Yes.
It's not solid, is it? That'd be dumb.
A covered bridge?
Yeah.
Yeah, they're solid.
I thought the walls were usually like a lattice, so wind could pass through, no? And they had a roof and like a latticey, side.
Is that right?
Yeah, maybe there's all kinds.
Yeah. I think those are just to keep the rain off.
Oh, yeah. That's what you said earlier. You keep shooting down the theory
The
of
structural
support.
thing. Yeah. But anyway, trusses rock, I guess, is what I'm trying to say.
Yes. There's your t-shirt. Trusses rock. So, are we at arches?
Did we say that they frequently use trusses to support beam bridges?
Yeah.
Okay.
Arches. Now, when we say a bridge is an arch bridge, the deck is not some big hill that you drive over. The deck is flat. The arch is underneath.
Right.
Yeah.
Yeah.
And you can have a single arch if your span isn't that long, or you can have a big one with like 6 or 8 arches.
Although I think there are like short arch bridges that actually do go up and down.
Oh, sure.
You know, like
I mean, there's
decoration
natural arch
usually.
bridges, like rock formations that
Yeah.
are like that, and that's why they're still standing.
There's a bridge that forms like a perfect circle. So like when you see it reflected in the water, it just looks like a circle.
Oh, neato.
Isn't that neat?
Yeah.
Arch bridges are pretty cool too. They're no trusses, but they're beautiful in their own way.
Yeah, that's true. So the arch is obviously semicircular. And like you said, if it meets the water and reflects nicely,
Fully circular.
fully circular. And the entire form is going to divert weight onto what are called abutments. And this is what takes on the pressure. It's like, if it's just a single arch, those abutments are probably going to be part of the earth
Right.
on
yeah.
one side or the other.
Yeah. And the whole point of an abutment is when you press down on an arch or when, gravity pushes down on it or it's compressed, that force goes downward and it makes the sides of the arch go out.
Yeah.
Those abutments press inward so that the force of compression just goes straight down through the arch circle, the semicircle,
Yeah.
and into the earth or into the ground or whatever.
Yeah, and it's the arch. What I thought was interesting. It's really all about fighting that compression. There isn't a lot of tension
Right.
that comes into play with an arch bridge.
I think the tension grows more and more possible when the degree of the arch grows.
Oh, okay.
Yeah.
So that could come into play.
It can, but for the most part, when you're building an arch, you have to worry about compression more than tension.
Gotcha.
Yeah.
So there's stylistically and artistically, design-wise, there are all kinds of arches, Baroque arches, Renaissance arches, Roman arches. The Romans built, arch bridges that are still standing today.
Yeah. Have you been to Rome?
Yeah.
Man, it's just like you're walking along and all of a sudden you look to your left and there's like a 2,000-year-old aqueduct.
Yeah.
1,500-year-old arch just sitting there.
Yeah. I remember the first time I went to Europe coming back and being sort of like bummed out,
Yeah.
because we're walking along and there's Burger King,
Right. Yeah.
Yeah.
This
just-
house is 200 years old. And you're like,
Right.
you should go to Rome.
I know my house is like 80 years old and it seems super old.
Yeah.
Nothing.
Not by Roman standards.
No. But, a little drafty in those 1,000-year-old apartments.
Yeah, but it's so neat though because there's so much old surviving stuff.
Yeah.
That not all of it's even meant to be preserved. Some of it's just there. It's not
Yeah.
like a part of a park or an historic exhibit. It's just part of the city.
Yeah.
Yeah.
I've heard other tourists complaining about how dirty Rome is. And I'm always just like, come on. It's like,
You're focusing on the wrong part.
it's been around for a long time.
Yeah. Oh, yeah, that too.
Yeah, and also, don't be stupid and just look around you. Like they're complaining in front of a 2,000-year-old fountain.
I didn't notice it was particularly dirty. I mean, it wasn't any more dirty than like New York or anything.
Yeah, any other big city. I
Yeah.
agree. But the thing with the arch, though, very stable once you get it built. But the building process is tricky because until you connect those two ends, that's what gives it its strength. So until that happens, it's a little dicey.
Yeah, oh yeah.
Gotta have some scaffolding going on.
Yeah, and they used to build wood scaffolds and supports to hold the thing, and then you just would build it in.
Yeah, that makes sense.
Now they use suspension cables. Like, I think the biggest arch bridge on the planet is West Virginia's New River Gorge Bridge.
Man, that thing is unbelievable.
It really is. And what's cool is when you look at it, it uses the cliff walls or the walls of the gorge as the abutments. Mm-hmm. Beautiful stuff.
Super strong. And that's where we're going to talk about that in our base jumping episode.
I know. That's the fact that ties these two podcasts together.
That's where they have Bridge Day.
Talk about elegantly simple.
So, suspension bridges, for my money, are where it's at.
I think they deserve their own episode.
Oh, yeah?
Pretty much. They're that complex. Like, this is just the briefest overview of bridges in general, but especially with suspension bridges, it feels like there's just so much going on with those things.
Yeah, I agree.
I mean, Ken Burns did like an 8-hour-long documentary on the Brooklyn Bridge alone.
Yeah, that's true. He's a deep diver.
He really is.
We're over you guys.
Yeah. With a giant helmet to go over his giant haircut.
He does have pretty big hair, doesn't he? All right, so suspension bridges, we mentioned, of course, Golden Gate Bridge and the Brooklyn Bridge. This is when you have your deck, your roadway is suspended by cables.
Yep.
Between, can be a number of them, but at least two tall towers.
Right.
That are supporting all of this weight, and compression is pushing down, traveling up through those cables, and is transferring all that compression through all those lovely cables.
Right. So, I mean, another way to look at it is exactly what it sounds like. It's the bridge is suspended from cables, right?
Yeah.
But if you really start looking into what it's doing, it's not just holding these things up. What's going on is there's a transfer of that natural compression of the deck up through the lines, up through the cables, up to the towers, which, like you said, send them down to the earth, right? Yeah. So the towers that hold the bridge up are at the same time distributing or dissipating the forces of compression that are trying to pull the bridge down into the water below it.
Yes.
And the tension you also have to deal with as well. And apparently you deal with that using another part of the structure of suspension bridges, which are called anchorages.
Yeah, now that's just what the tower's connected to at the base, right? No?
No, So it's like... the
anchorages is like the abutment, essentially.
Yes. Yeah.
They're on the left and right.
They're like a suspension bridge's abutments, whereas as you get closer to the middle of the bridges, that's where the towers are.
Yeah.
But on the very ends, like say where the roadway hits the bridge, you're going to have a massive piece of rock or massive piece of concrete, and those are the anchorages, and you have horizontal cables that distribute the compression from the bottom of the bridge to the anchorages, and those transfer those into the earth.
Yeah, and you might also, depending on the size of your suspension bridge, have to have that below deck truss as well to help stiffen the deck. And, you know, if you have a 4,000-foot bridge, you're going to have all kinds of trusses and decks and cables. And I think I finally figured out what it is about bridges that I love is that the structural design that it needs to be strong also happens to be beautiful.
Yeah.
You know what I mean? Mm-hmm. Like the way the cables are arranged, it's not like they're like, oh, this looks great. It's like, well, it has to be like this,
right? But
it also happens to be very striking.
Like Grace Jones. You know what I mean?
Yeah, absolutely.
So suspension bridges are your favorite, huh? I like them because they have so much going on.
Yeah.
I like trusses because they're so elegantly simple. And they're just tough as nails.
There's a bridge for everyone, I think.
There really is. The cable-stayed bridge And we should say that suspension bridges, when you think of a suspension bridge, you probably think of the Golden Gate Bridge or something like that, right?
Yeah.
Just a classic suspension bridge. 2 towers, 2 anchorages, lots of suspension cables. It's a suspension bridge. Mm-hmm. And you think, well, then they're probably pretty new. Wrong. Suspension bridges have been found in various forms for hundreds of years at least. And apparently the Inca were masters at building rope suspension bridges out of woven grass.
Crazy, man.
Yeah.
1500s, they've discovered the Spanish conquistadors stumbled upon these and were like, what in the world is going on here?
Right.
Because the smart Europeans didn't figure this out for another few hundred years after that.
That's right. The Inca still have one of these bridges intact. It spans 90 feet. And they remake it every year as part of a 3-day festival.
So, oh, really?
Mm-hmm.
Nice.
Yeah, which is why it's still intact. Because a woven grass rope bridge doesn't last all that long necessarily, even though when it's fresh and new, it's strong.
Yeah. Has an expiration date. Is what you're saying.
But apparently, as we'll learn, all bridges have an expiration date.
Ooh. All right. Well, we'll take a break then with that tease and talk about the cable-stayed bridge and then how you might die on a bridge one day.
Stuff you should know.
We've all had the experience of calling a business and just wanting to talk to a real person. Not an automated voice pretending to be human, an actual person who can listen and understand and offer help.
That's exactly what you can do with Ruby. Ruby is the virtual receptionist company that takes care of your callers when you're unavailable in the middle of something or simply don't want to pick up.
That's right. They can answer, screen, transfer calls. They can take messages, collect payments, book appointments, and more, all while making the people you serve feel special.
And best of all, it can help you be more productive. For example, 9 out of 10 lawyers who use Ruby log more billable hours per day than the national average.
And other professionals like plumbers and technicians win more customers while being able to stay focused on the job. But whatever kind of small business you run, Ruby is built to save you time, earn you more customers or clients, and make meaningful connections with the people you serve.
It's available 24/7, 365 days a year, and 100% based in the U.S. See why more than 15,000 small businesses use Ruby. Visit Ruby.com, or better yet, call them at 844-900-RUBY. Work can be a little weird. One minute you're in a meeting that could have been an email. The next you're trying to decode corporate jargon that somehow means nothing. And don't even get us started on the quick sync that turns into a 45-minute deep dive.
Yeah, well, the truth is figuring out your career isn't always straightforward. Whether you're trying to grow, pivot, or just stay relevant, it can feel like you're navigating it all on your own. Well, that's where LinkedIn comes in.
That's right. LinkedIn can help you grow your career, helping you confidently navigate your path with insights, ideas, and inspiration from your professional community. You can stay up to date with the latest trends in your field, connect with people who get it, and discover opportunities tailored to your goals, your experience, and what actually matters to you.
Whether you're looking for something new or just trying to grow where you are, LinkedIn gives you the tools and connections to move forward with confidence. Because LinkedIn is the network that works for you. Visit linkedin.com/knowstuff to learn more.
All right, so we're on to your favorite, my friend. The super sleek, modern-looking cable-stayed bridge, which is actually has been around since World War II.
Yeah, but the idea
which is still modern.
The idea came from a dude named Faust Vranchik.
Yeah, man.
And he was a contemporary of Kepler and Brahe, and he basically came up with the first design for a cable-stayed bridge back in the 16th century.
So what's the nuts and bolts of this thing?
So basically it is rather than 2 towers, like a suspension bridge uses, a cable-stayed bridge uses 1 tower.
Well, not always. There's plenty of them that have more than one, but...
Okay, but for a particular span of bridge,
yeah,
there's 1 tower supporting that one span, right?
Yeah.
So it's basically, you can't use it for as long of a span as a suspension bridge.
Right.
But if you have a slightly shorter span and you don't want to spend quite as much money and you don't want as many wires up there and everything, you can go with a cable stay bridge. So you have usually one tower holding up all of the cables, and the cables can either all connect to one point, which is called a radial pattern.
Yeah.
Right? So it's like all these different cables are connecting on the bridge deck at different points.
Yeah.
But they're all connecting at about a single point on the tower.
Again, architecturally lovely.
Very neat looking.
Yeah.
And then another way that you can do it is in a parallel pattern. So they're connected at different points on the deck, and they connect at different points on the tower. And that's the case with the Erasmus Bridge, which I think is the most beautiful bridge in the world. It's in Holland.
Oh, wow. Wow, that doesn't surprise me.
I mean, look at that thing. Look at that. Pow.
Oh, yeah. That's something else.
Yeah. I wish you guys could see this.
Well, they can look it up. It doesn't look like very Dutch, though.
No, it looks very,
It's like the New Holland, I guess.
yeah, New Amsterdam.
I'm just picturing like Holland. I think of, wooden windmills.
Oh, and like tulips and stuff like that?
Yeah.
Sure.
Yeah.
Yeah, this is modern Holland for sure.
It looks like something that would be in like Sydney, Australia.
Yeah. Well, they have great bridge too.
They do. Mm-hmm. Maybe that's where I'm thinking. Living bridge. Well, are you done with those?
Well, I was going to say another design for cable stay bridge looks a lot like a sailboat.
Yeah.
With the tower standing straight up, and then on each side cables going down at a diagonal from it to make it look like a sailboat sail.
Right.
And mast.
And again, for structural integrity more than anything.
Right.
Living bridges?
Sure.
Well, I guess we should say cable stayed bridges are, they can't be as long as suspension bridges, but they can be pretty long.
Yeah.
Like up to close to 3,000 feet.
But that's what I'm saying. Like if you have a shorter span and you don't want to use as many materials and hence spend as much money, a cable stay bridge is a great alternative.
Yeah. I wonder when cities, I wonder what the considerations are. Like money,
I would guess money first and foremost.
Money, what you probably is best for the land, but I also bet that architecture comes into play, like how it looks in the cityscape, don't you think?
Yeah. Like usually a city will have some sort of, will accept several designs, competing designs, and then probably, well, like in Atlanta's case with the 17th Street Bridge, goes with the cheapest one,
right.
And then half of it falls down onto traffic later, like a couple of years later.
Did that happen?
Yeah.
When?
Like two years ago.
Really?
Yeah, man, it was a big deal. Luckily it happened at like 4 in the morning or 5 in the morning, but like when you're walking on the bridge, the side stuff?
Yeah.
One whole side fell over onto 75 below. Onto the connector right below it.
Yeah, I kind of remember that.
Yeah. But it's an ugly bridge to begin with, really.
Yeah.
And dude, if you're listening, the guy who designed it, I'm sorry, I don't mean to insult your work, but
but do better.
The city could have done better, I think.
Yeah.
But I think what it came down to, I'm sure, was all of these are beautiful, but we're just going to spend the money on this one.
Right.
You know?
Or whoever got the biggest kickback.
Yeah.
Or wherever that came from. Not to be cynical. Living bridges?
Yeah, we were talking about that.
If you go to northern India to the Meghalaya region.
I think that was good.
All right, close enough. They have something pretty remarkable, and they are called living bridges. And what they did was, it's so rainy there that all of their natural bridges were having a hard time staying intact because of all the moisture.
Yeah, for monsoon season.
Yeah, and that's, you can't have a natural bridge with that much water. So they said, why don't we take these tree roots and grow them out of the ground and span a river over the course of years and years and years,
right.
And then basically plant it on the other side into the ground. And this is now a natural tree root bridge.
Right. It's like giant living bonsai. Like they were training roots to go a certain way. And they would take a tree, a felled tree, and split it in half and use that as the guide.
Yeah.
right? It's like the structure. So it's
Sure.
like they were building an arch, but they weren't making an arch.
Like sort of a temporary bridge.
Exactly. And they let the roots grow along that. And like they would plan these things out, or they do plan these things out over the course of like a decade.
Yeah.
And I get the impression it's the whole town's responsibility, or at least some people in the town's responsibility, to make sure that if you see your root starting to go down in the wrong place, you just pluck it up and put it back on that felled log that's guiding it across the way.
Yeah, it's pretty neat. Like, it requires patience, obviously, but it also, I imagine just once a day someone walks down and is like, yep, looking good.
Yeah.
And then just walks away again.
Pets the bridge, says,
Keep growing.
I'll walk across you in 10 years, buddy. And apparently those things can last up to 50 years, or the largest one that they have, up to 100 feet, which is 30 meters for our friends in India.
Crazy.
And it can bear the weight of 50 people.
And lasts up to 500 years, not 50.
That's what I said.
Oh, I thought you said 50.
I said 50 people.
Oh. Well, it's crazy. Like, you got to Google these things.
Yeah, they're very pretty.
Very pretty.
It looks very dark crystal-y.
Oh, yeah, totally.
You know what I mean?
Mm-hmm.
But they're not unsettling at all.
No.
Like the dark crystal.
Right.
Which, by the way, if you're ever in Atlanta, sometimes people say, hey, I'm coming to Atlanta.
Yeah.
What should I do? Go to the Center for Puppetry Arts.
Agreed.
And just look at their free exhibit,
Yeah.
which includes a full-size Skeksis. It's terrifying.
Yeah, they have, we've talked about this before, they have Emmett Otter on
Oh, yeah,
display as
that's
well.
right. Yeah.
For me, that was pretty magnificent.
Oh, it meant a lot for Emmett Otter to meet you, too.
They're doing, actually, I was just at the Museum of the Moving Image in Queens.
Oh, yeah, I saw you post something about that.
Yeah, they have a Mad Men exhibit right now, which is pretty neat. But
it was pretty cool.
I was not there in time for the Jim Henson one. They're putting that in place, I think, for later.
Oh, it's coming?
It's coming.
Well, that's good. You didn't miss it yet.
Well, yeah, I'll just go back.
We went to the Yoko Ono exhibit at MoMA.
Uh-huh.
Awesome.
She's something else.
Dude, she's got a pretty cool mind.
Yeah.
She had this one display, and it was titled 3 Spoons, and it was just 4 spoons in a row.
It wasn't 3.
No.
I love that stuff.
Yeah. So I recommend that as well.
I'm not a fan of her music, though.
I actually got turned on to her music in the listening room there.
Yeah.
Plastic Ono Band.
It's crazy,
It
man.
is weird stuff, but I kind of like it.
I mean, she's definitely one of the most, like, original thinkers, out there.
And she's been at it for a while. Like, a lot of the stuff went back to the 60s, like the early 60s.
Yeah. And talk about weathering criticism and still just being like, screw you.
Yeah.
I'm Yoko Ono. I don't care what you say.
Well, she was exonerated, too, recently. Remember, Paul McCartney came out
yeah.
and said, like, it was not Yoko Ono that broke up the Beatles,
No,
so
of
stop
course it
saying
wasn't.
that.
The
It
Beatles
just
were-
took them, like, 50 years to come out and say it.
Yeah.
You know?
She's like, would it kill you?
Right.
You've told me privately many times, but little press release.
Just tweet it.
All right. So we talked about compression and tension being the two main forces. There are quite a few other forces, dozens even, that can act on a bridge in a negative way. And the scariest one, for my money, is torsion. If you've ever seen the video, it's a very famous video of the bridge. What is it? The Tacoma
Narrows Bridge.
Tacoma Narrows Bridge, when it looks like a wet noodle twisting in the wind.
Yeah, it was 1940.
It's nuts.
And they have, like, footage of this whole thing just undergoing this destruction that kept just going on and on and on, and finally the bridge just comes down.
Yeah, the craziest part is when you're watching it, you just think, oh man, look at that thing. It's nuts. And thank God there's no one on it. And then you see like a dude walking on it in a car.
Yeah, and a guy ran. There was a dog. There was one car in there, and there was a dog trapped in the car, and some guy ran and got the dog.
Oh, he did?
Yes, pretty great heroic stuff.
Sure.
Then later on, I don't know if it was the same guy and another guy or just two completely new guys. They're just walking along it. This is after a whole section has fallen into the river,
Yeah.
but the section they're walking on is still swaying.
Or they're
It's
just like, this
get
is
away
neat.
from the bridge. Step back from the bridge, man.
So that's torsion at work.
Yeah, and that's a big problem that designers of suspension bridges face, because you have a deck that's being held aloft by cables, right? It's not like fixed to anything below it necessarily.
Yeah, I mean,
it's being suspended. So just like on like a rope bridge or something like that, it sways very easily, right?
Yeah, those towers are strong, but it's not, directly connected to those towers.
Right. So if you have a swaying bridge in between them, right? And the thing is swaying back and forth, but if one side starts to sway over the other side, then all of a sudden you have an opposing circular force, and that's torsion. And that can basically rip the bridge in two, which is shear.
Yeah, well, that's the other awful thing that can happen. It can just snap. Well, not snap, I guess, but just break into two parts.
Yeah. Well, I mean, snapping is the result of compression.
Yeah.
So shearing would be what it's called technically.
Yeah, exactly.
Where the same span of bridge has the two opposing forces acting on it at once, in opposite directions, and it goes whoosh. It makes that terrible sound.
If you want to combat torsion, many ways to do this. You're probably going to have a deck truss going on.
Yeah.
To help out.
Truss saves the day.
Deck truss saves the day. You're going to have, you're going to do wind tunnel tests if it's a modern bridge beforehand.
Well, you're going to make a model.
Yeah. And do tests and see how does wind affect this bridge and what do we need to do?
But the thing is, with the Tacoma Narrows Bridge in particular, they did tests. They had that thing rated at withstanding winds of up to 120 miles an hour. But the winds that day that brought it down were only 40 miles an hour. And for a long time, they were like, what happened? And somebody said, you know what it was? It was mechanical resonance.
It was, the deck truss was not sufficient for the span.
That was part of it.
And the way that the wind hit it.
Right.
And the angle caused the final thing, like you just mentioned, resonance, which is it's a vibration basically that gets out of hand.
So resonance to me, I think, deserves its own podcast too.
Yeah.
It's awesome. Everything, especially anything that we build, from an airplane to a bridge to a watch, it has a certain frequency where it will really pick up force, really absorb force. It'll run through it, right? So let's say that your bridge has a resonance that's like at a frequency of 10.
Yeah.
That's probably a totally ridiculous number that I just said, but let's say it's 10, right? And then let's say that wind comes at it at 40 miles an hour at just the right angle, and it makes it sway at a frequency of 9. Well, that bridge is it's just going to sit there and sway. Not a big problem. If that wind hits it at just the right angle, at just the right speed, and it starts swaying at 11, it's still not quite a problem.
Yeah.
But if it gets it just right and it starts swaying at 10, all of a sudden those sways are going to become more and more pronounced because all that energy is flowing through at its maximum potential, at its freest flow, because it's hitting the bridge at its natural resonance, right?
Yeah.
And that's what caused the Tacoma Narrows Bridge to come down. Because once that thing starts going, there's no coming back from it.
Oh, yeah. Well, you can see it
happening.
happening. It gets worse and worse.
Exactly. And that's because it hit it at just the right frequency.
Yeah, they liken it in the article, which I think is pretty down to earth, of a snowball rolling downhill.
Exactly. It just keeps getting worse and worse, and you can't stop it. So, but isn't that bizarre that a bridge has a natural resonance, a natural frequency?
I don't think so. I would assume it would vibrate.
Yeah, it did not occur to me at all. And I was talking to Adam about this too. And I was like, so I saw that building designers, bridge designers, they will fine tune like a structure so that it resonates at a frequency that it's probably never going to encounter from an earthquake or from winds or whatever.
Yeah.
And I'm like, how do you do that? And apparently it comes down to the building materials you use, the shapes you use to form the structure, the way you join those shapes together. And you can basically say, I'm giving this building a frequency of 1.5.
Right.
Whereas I know all of the wind in the area and the ground movement from an earthquake is going to make it vibrate at a frequency of 7. So it'll be fine.
Yeah, and one way, like you said, they can do that is by not having shortening the sections of the deck, let's say.
Yeah.
And that way the vibration, when you have these overlapping plates and smaller sections, it's going to create enough friction to disrupt that frequency.
Right. It'll change the frequency that the bridge is moving at. But I mean, and not just bridges too. You have to take into account like airplanes, right?
Sure.
You can't use engines on airplanes that create vibrations at a frequency that's at the natural resonance of the airplane body.
Yeah.
Or else the airplane body is going to come apart just from turning the engines on.
Yeah. Could you imagine seeing the airplane wing starting to flap like harder and harder?
Right. But apparently the more common thing when you have a disaster, a catastrophe from a mechanical resonance problem, it's like one bolt is like, I can't take it anymore, and stops. And then that leads to a cascade of failures that ultimately has the bridge coming down.
Yeah. Interesting.
I think that's fascinating. I had no idea that you had to worry about frequencies and vibrations. I mean,
maybe
I get
that's why all the bridges you've built have collapsed.
They collapse pretty easy.
Well, if you've ever heard the old...
they go down like a French boxer.
I don't even know what that means.
I don't either. But it was a Glass Joe reference. Remember him from Mike Tyson's Punch-Out?
Oh, no. Was that one of the guys?
The first guy you encounter?
He says...
He was French. Glass Joe.
Oh, gotcha.
Instead of glass jaw. And he went down just like a sack of potatoes. So easy.
Man. Well, which was it? A sack of potatoes or a French boxer?
He was both.
He went down like a sack of French potatoes.
Yes.
French fries.
Right. My bridges go down like a French boxer, but Glass Joe, the French boxer, went down like a sack of potatoes.
Gotcha.
Ergo, my bridges go down like a sack of potatoes.
If you've ever heard the old wives' tale that like an army marching across a bridge in step can cause enough vibration to take down that bridge.
Yeah.
It's true. That could happen.
Yep.
So
if they do
wartime,
it at the right frequency, right?
Yeah, in wartime they will break step. In other words, their rhythm isn't all the same to avoid that scenario.
And there was a bridge disaster I saw in that Time magazine slideshow where that happened. There were a pair of skywalk bridges inside the Hyatt Regency Kansas City hotel. In the lobby. They were just like, raised bridges going through the lobby, and they collapsed in 1981 and killed like a bunch of people.
Because
like
of
30-something people.
People marching?
Dancing.
Oh.
They were dancing on the skywalk. And you think like, up to today or yesterday when I started researching this, right? Like, I just thought that's weight or pressure or something. Like, if everybody's dancing, it never occurred to me that the rhythm had something to do.
Oh, really? See,
yeah.
I'd always heard that.
Well, you are far more advanced than I am in structural engineering, my friend.
Not that. It's just I always heard that, like, even a bunch of kittens walking across could cause that. And the reason they said kittens, of course, is so it has nothing to do with weight.
Right, because kittens don't weigh nothing.
And consequently, I think Lionel Richie had to change the name of that song because of the accident. I think originally it was
Hello?
Oh, What a Feeling when you're dancing on the skywalk. And he had to change it to ceiling, and everyone was like, that's weird. You can't dance on a ceiling, but it rhymes.
He's like, yeah, but nobody ever died from dancing on the ceiling.
I guess the final thing we should mention is that weather obviously will play a big impact. We already talked about wind, but over the years, the materials they use and the design has gone in to take account things like wind and sun damage? I don't know what else.
I think the freeze-thaw cycle is huge.
Yeah.
Salt.
Sure.
Salt exposure, if it's going over like a salty body of water.
Yeah, that makes sense.
Yeah, there's a lot of things that are trying to bring a bridge down. Nature abhors a bridge, basically, as much as a vacuum. I've got one.
What you got?
There's probably around 630,000 bridges in the U.S. alone. Because there were 617,935 in the 2002 census, and they were adding them at about 1,000 a year, maybe 900 a year.
Wow.
That's just the U.S. The world's longest bridge, completed in 2010, the Danyang Kunshan Bridge.
I think I've seen pictures of that.
It serves as a railway bridge for the Beijing and Shanghai Railway. It's a 102-mile long bridge.
That's nutty.
Over water.
I'm a big fan of cities with multiple water bridges.
Well, that's why you liked Pittsburgh.
Pittsburgh, Portland, Budapest.
Yeah.
I'm a big fan. Atlanta does, we have bridges, but it's not like you have to go to the Chattahoochee River or to the lakes.
Nobody goes to the Chattahoochee,
What? Sure.
I got one more thing. I want to shout out to PBS's Build It Big website.
Yeah.
Which is like beyond 90s as far as websites go. But it was extremely helpful in understanding the forces that work on bridges, different types of bridges, different specific bridges.
Yeah.
Great website.
And thanks to Adam, I guess you got some information from him.
Yeah, thanks, Adam.
Was he into talking to you about it, or was he on the other end going, "Oh my God, Josh, shut up! I'm watching Tim and Eric"?
He was into talking about it.
I figured he would be.
Yeah. And I actually have to shout out to Yumi too, because I told her we were building we were talking about bridges. She sent me a bunch of stuff on popsicle bridges.
Oh.
Apparently there's a Indiegogo for the world's strongest or Canada's strongest popsicle bridge.
Wow.
Yeah.
They're trying to build that?
Yes.
And
they have like six grand already.
Man.
Out of popsicle sticks.
Good for them.
So that's everybody getting shouted out to all over the place in this one, huh?
Yeah.
That's nice stuff. Bam. If you want to know more about bridges, you can type that word into the search bar at howstuffworks.com. And since I said search bar, it's time for listener mail.
I'm going to call this, I got a couple of street gang responses we'll read over the next couple of shows.
Okay.
Here's one. I had to write in about your street gangs episode as it was interesting and pertains to my job. Short version is that I work for a hospital-based program, and we see every gunshot wound victim and stab wound victim who comes through, which is about 400 to 500 a year, and about 10% of those are gang involved. You guys have mentioned how you found the number of gangs to be hard to believe, but I think you may be thinking of street gangs as one entity that has strict borders and lots of people. In my experience, larger gangs will sometimes incorporate smaller gangs, and sometimes larger gangs will split off into many, many smaller groups. People go in and out of gangs and are sometimes affiliated with more than one. Currently, we have about at least 70 in our city alone, and a substantial amount of those have less than 20 members. So they're like mini gangs.
Gotcha. Not super gangs.
Not super gangs. According to this paper on street gangs in Boston, 18% of the gangs in the city have less than 10 members, and 34% have 10 to 19 members. So while the numbers you gave seem shockingly high, they also seem to be in step with the current climate. And that is from Ariana.
In what city did she say?
You know, I don't see that. I don't think she said. I don't know if it was Boston or if she just referenced Boston.
Well, thanks a lot, Ariana. We appreciate that email. And yeah, keep them coming. We want to know more about gangs. I just had the impression the whole time that, like, one way or another, we were officially or unofficially misinformed.
We may be.
And also, let us know who's the coolest famous person you've ever met. You can tweet to us at SYSK Podcast. You can join us on Facebook.com/Stuff You Should Know. You can put it in an email to stuffpodcast@howstuffworks.com. And as always, join us at our home on the web, stuffyoushouldknow.com.
For more on this and thousands of other topics, visit howstuffworks.com.
Every parent should know the car ride soundtrack. Are we there yet? How much longer? I'm bored. Well, if you're taking an extensive car ride anywhere and you've downloaded the Lingo Kids app prior to leaving the house, you may experience something strange, right, Chuck?
That's right. You may experience silence from the back seat. Your kid may go an entire car ride without asking once if they were there yet. How about that? And by chance of miracle, they may even ask if you could drive longer.
Yeah, that's the magic in Lingo Kids. Over 4,000 interactive games, songs, and shows, including their favorite Disney characters. It turns the longest drives into the easiest ones, and honestly, you won't understand why you didn't download it sooner.
That's right. Lingo Kids is the #1 entertainment platform for young kids, and it's free to download. Or go plus with the Lingo Kids subscription and unlock even more content your kids won't be able to get enough of. You can save up to 60% on the yearly plan. Just search Lingo Kids in the App Store or Google Play. Lingo Kids, everything kids love.
Imagine never buying gas again. Well, you can with an electric vehicle. EVs are easy to charge as your phone and perfect for everyday life. You can drive daily with confidence everywhere you go. Most Americans drive just 40 miles a day, and most EVs are equipped with 200 to 400 miles of range. Plus, they've got fewer parts, they require fewer repairs, and they produce fewer headaches. And with all those pluses, it's no surprise that we're seeing more and more EVs on the road, which makes the planet happier and happier. The way forward is electric. You can learn more about EVs at electricforall.org.
This is an iHeart podcast. Guaranteed human.